All right, so today we're talking about creating equations. In order to do that effectively, we need to be able to talk about uh, the way that we write or say different mathematical terms in words. So first we're going to just quickly review the most simple mathematical phrases, which I have listed right here to the left. So I have sum, difference, product, and quotient. So the sum is the solution to an addition problem. Difference is the solution to subtraction. Product is multiplication. Quotient is division. So if I have phrases that use these terms, I want to be able to write them as expressions. So if we look down here, I have the sum of 5 and 7. So since the sum is with addition, sum is 5 plus 7. Versus the difference is subtraction, so difference of 12 and 9 is 12 minus 9. The product of 4 and 6, so 4 times 6. And the quotient of 27 and 3. Now I'm going to go ahead and advise you to write 27 divided by 3 like this instead of like this. This notation just makes things a lot easier as you continue doing math in the future. So these were very simple. We're going to do that same thing with some slightly more complicated phrases. And I'm just going to go ahead and think out loud while I do them because I think that's probably the easiest way for you to follow me. So it starts with the sum, and we just talked about above, the sum is addition. So I know I'm going to be adding something. So the sum of 5 times a number n, 5, so I have a 5, then I'm multiplying that by some number I'm calling n, and it's the sum of that and, so the other side of my addition sign is 13. So the sum of 5 times a number n and 13 is 5n plus 13. And then number 2, I start with the quotient, and we just talked about how that's division and it's easiest to write in fraction form. So it's the quotient of 4. Well, that's easy enough, so let's start with a 4. And so the quantity, this phrase is just letting me know that everything right here is all together. So my 4 goes on top, and then this whole section is going to go on bottom. So I have 2 less. If I have 2 less than something, I'm going to subtract 2. And it's 2 less than 1/3 of some number x. So I have 4 over 1/3 x minus 2. Then the last one starts with the difference, which is subtraction. So it's the difference of 6 times a number x is my first part. So I have 6x. And the quotient, so I'm going to be dividing again, of the number x and 5. So I have 6x minus x over 5. So this same idea we just talked about can also be applied going in reverse. If we're given an expression and we want to be able to write that in written words or speak it verbally. So that's what we're going to do on numbers 4, 5, and 6. So I think the easiest way to start is to look at whatever the main operation we're doing is, which in this case is subtraction. And subtraction I use with the difference. So I have the difference of this and this. So I'll start with the first part of 5 and the second part. So I'm dividing here, so it's the quotient of some number x, so of a number x. And now in some problems on your assignment, it will just say a number. It won't say x. And in that case, basically, it doesn't matter that our variable is x. It can be any, you can use any letter that you want to represent your variable. So you could put an n or a p or a j. So if it just says of a number, you can choose to use x, and in this case it does use x, but you could also use any other variable. So it's the quotient of a number x and 76. And then number 5, again, I'm going to start with the main operation, which this time is addition. So I'm starting with the sum. And it's the sum of 4 And my second part is 1/3, and again, of a number. In this case, it's x, but you could pick whatever variable you wanted if you were the one writing the expression. So now on number 6, each part of my addition problem is kind of a big thing. So the way that they did it in the expressions we have above in our notes is they would call these two things quantities. So it's the quantity of the sum of x and 2 and the quantity of the quotient of 7 and a number x. So that is great. If you like that way, do it that way. I'm going to show you one other way you can do it, and it's using quotations. So if I put this part in quotes and this part in quotes, then it's clear that I'm talking about the sum, because this is addition, of this part and this part. So if I start with my first part, I've got my quotes, and that is the sum of a number x and 2. And now my second part, again in quotes, is the quotient of 7 and a number x. So that way you're making it clear that you're adding this part and this part, which you could also do by using the phrase the quantity. The next part we're going to talk about is to be able to create equations from a story problem. So the biggest thing when working with story problems is that you read them slowly and carefully, and that you don't give yourself a mental block. Like, I find that many students will see story problems and they're immediately like, oh no, I hate story problems, and they kind of give up before they start. But really, the math is not very difficult once you kind of wrap your head around what it's asking. So I'm going to think aloud for these as well. So I'm starting with a car salesman, and he earns a $30,000 salary. So I'm just going to go ahead and write that down. So a $30,000 salary plus, so I'm probably going to be adding something to this, a commission of $600 for every car he sells. So as I read through the rest of the problem, he wants to earn $80,000. How many cars does he need to sell? So I don't know how many cars he sells. That's going to be my variable. So my x is going to represent how many cars. So if he's earning $600 per car, he's earning $600 times however many cars they are, which we don't know that, so that's going to be our variable. That's our x. And he wants to earn $80,000. So now, once I have my equation written, I can just solve it, which we've been doing for a long time. So I'm going to go ahead and minus 30,000 from both sides. And these cancel. And then I have 600x equals 80,000 minus 30,000, which is 50,000. Then my last step to get x by itself is to divide by 600. So 600s cancel, and 50,000 divided by 600 is 83.3. Now, it doesn't really make sense for me to sell 83.3 cars, right? So if he really wants to make $80,000, he's going to have to sell at least 84 cars. Some people are tempted to round this to 83, but that would be less than how much he needs, so that's not going to work. You've got to round up in this case to 84. Number 8, we're talking about a school football game. So the school charges $5 for students and $8 for adults. So I don't know if it's going to tell me how many students or how many adults yet, but I'm just going to use variables for now. So S for students plus 8, A for adults. And the football team really wants new uniforms that cost $1,200. If 50 adults come, so right there it told me my A is 50. How many children, or students I should say, need to be with them? So I know what A is, I don't know what S is, so that's what I'm trying to solve for. So I'm going to go ahead and plug my 50 in for A. So I have 5S plus 8 times 50 equals 1,200. So if I multiply that, I have 5S plus 8 times 50 is 400 equal to 1,200. Then I can minus 400 from both sides. So I have 5s equals 800. Divide both sides by 5, and 800 divided by 5 is 160. So 160 students have to come in order for them to make $1,200. Number 9 is very similar to the ones that we started the day with. So we have 3 more. So if I have 3 more than something, I'm going to have plus 3. So 3 more than 6 times the square of a number. I'm going to call this number x. You can call it whatever you want. So I have 6 times the square of x. So 6 times x squared. Add 3 to that, and that is, or is equal to, 57. So then I can go ahead and subtract 3 from both sides, which gives me 6x squared equals 54. Then divide by 6 on both sides, and x squared equals 9. And to get rid of this squared, I can take the square root of both sides, and the square root of 9 is a positive or negative 3. Not sure which. So in this case, my x is equal to plus or minus 3. Number 10 is about Bobby, who's having a serious growth spurt. So he's currently 34 inches tall. And this is saying if he grows 2 inches a month, and as I look through the rest of the problem, how many months will it take? So I don't know how many months, that's my variable, for him to reach 4 feet tall. So the thing I have to be careful with here is I'm looking for him to reach 4 feet, but I started with inches. So 4 feet in inches, there's 12 inches in 1 foot. So 4 times 12 is 48. So instead of putting equal to 4, I'm going to put equal to 48. And then you can go ahead and solve for x. And I'm going to let you do that because I want to make sure I have time to do number 11. So number 11 is about Savannah, who's making a square garden. So I'm going to go ahead and draw that. So I have square garden. Don't know what my sides are yet, so I'm just going to call them x. But she realizes that this square is too small. She wants a bigger garden, but she only has room to extend it 2 feet on one side. So we're going to add 2 feet to one side and 3 feet on the other side. So we're going to add 3 feet to the other side. Then the area of this garden is 156 square feet. So to find area, I multiply one side by the other side. So I'm going to have x plus 2 times x plus 3, and that's equal to 156. So I'm going to go ahead and multiply these using this distribution method, and I'm left with x squared plus 3x plus 2x plus 6 equals 156. So I can combine my 3x and 2x, so I have x squared plus 5x plus 6 equals 156. And this is looking like a factoring problem. So in order to be able to factor it, I need everything on the same side. So I'm going to subtract 156 from both sides. So I'm left with x squared plus 5x minus 150. So I need two numbers that multiply to negative 150 and add to 5, which in this case is negative 10 and 15. Since my a is equal to 1, conveniently, this immediately factors to x minus 10 and x plus 15. And if I set each of these equal to 0, I have x equals 10 and negative 15. So now I'm going to pause for a second and think about what was the question. So my question was, how long was one side of the original square garden? And one side was x. So I am looking for what x equals, but it doesn't make sense for my square garden to have two different answers. I can't have one length be one side and one be the other because it was a square. They've got to be the same. So one of these answers must not fit. And if we think about this logically, the length of a garden can't be negative 15. You can't have negative 15 feet as a length. So the only option that makes sense is 10. So one side of the original garden is 10 feet long.